Hello YouTubers and fellow hams. Well, this is part, what am I up to? 4, I guess, in the Backyard Vertical project. And in this part we'll be winding the 1-to-1 common mode choke that will go in the line about 6 to 8 inches back from the 9-to-1 feed point. And the common mode choke will greatly reduce the amount of RF coming back on the coaxial shield into the shack, as well as any other common mode noise picked up by the antenna or feed line. The other thing it does is, because of it reducing that RF coming back, it makes your antenna tuner happier. I use an automatic tuner, the Z11 Pro, from LDG. And I'd noticed when I've used 9-to-1s in the past without a common mode choke, that RF coming back on the shield of the coax can confuse the tuner when you crank the power up a bit. I get up to 100 watts and I'll see the SWR indicator on the tuner jumping all over the place, and it might want to retune right in the middle of talking, which is a bad thing. So the common mode choke reduces that effect quite a bit. As a result, since the 9-to-1 can't use the shield of the coax as a counterpoise, you do need to have counterpoise wires and a ground at your feed point at the 9-to-1. For the antenna to work properly. But anyway, let's get right into winding the choke. I have, I think, everything I'm going to need here, so I'm going to reposition you so you can look down on the table, and we'll get started. All right, what we're going to need for this common mode choke, just a couple of basic things. We'll need some diagonal cutters, a couple of zip ties, optionally a little length of heat shrink tubing, which I'm going to use to keep wires together while winding, a T130-2 toroid. You could go upsize to a T200 if you were going to wind it with a heavier wire for higher power. But with this and this 18 gauge wire, we should be fine for up to 100 watts, no problems. I've been doing that with my other antenna for quite a while. A Sharpie marker, optionally a pencil for making notes, a ruler, and of course, hookup wire. So this is 18 gauge, I think, generic wire. It's heavily insulated. Yeah, 18 gauge. The installation says it's good for up to 600 volts. So yeah, you're not going to get any problems with 100 watt power. So what is the common mode choke? What does it look like? Well, there you go. It's really simple. As you can see, we have our input connector over here coming from the radio. And then it goes over the top for the first wind. It goes in through the top, and then we do 1, 2, 3, 4 winds on one side of the toroid, and then it goes underneath and it comes back over the top again and straight across through the middle underneath. Okay, that's important because these winds have to be electrically 180 out of phase with these winds, so that common mode currents will cancel each other out. At least that's how I believe it works. I'm pretty sure I'm right on that, but I could be wrong. Yeah, if I'm wrong, I'm sure somebody will tell me in the comments. But at any rate, so this last wind comes over the top here, through the middle, and underneath this side, and then we do our other 4 turns in this direction, with this last one coming out the other end to our output connector. So that's all it's going to be, 8 turns total with this fancy little crossover at the far end here. Pretty straightforward. I'll let you freeze frame this if you want to grab that shot right there for this diagram. I can link the original drawing of this in the description. In the original drawing, he had this end just bare wires, and he called it a 1-to-1 ballon. Because he was connecting a dipole at this end, which would be a balanced system, to a coaxial feed line, which is an unbalanced system. But electrically, it's pretty much the same. It's a 1-to-1 common mode choke. So anyway, let's get going. So I've got my toroid, and the first thing I need to do is I need to determine how much wire is going to go around the toroid for my 8 turns. And to do that, I'm going to do similar to the way I did it before. I'm going to wind 1 turn around here of my wire, And then I'm going to take my marker and just, while that's being held tight, I'm going to draw a line across those two wires and measure the distance between those two marks. So I'll straighten that back out, get my ruler, and between those two marks we have 4.5 centimeters, or just shy of 2 inches. Hey, we'll just call it 2 inches because we're going to need a little extra wire at the ends anyway. So let's say 2 inches for one turn. And we've got 8 turns, so that's 16 inches of wire just to make the turns around the toroid. And then I'll add a couple inches at each end of each wire to allow me some room for making connections in the box at the end. So 16 plus 4, 20 inches. Let me measure out 20 inches of wire. There's 12. There's 20. And we need 2 wires, so I'll measure out another one. Keep forgetting to put my hands forward where they're in the shot. So there's my 2 wires. Now, in the 9-to-1 video, I wound them on the toroid, and then I used a multimeter to ohm them out and mark them at each end to keep the wires identified. And right away I had a comment, I think it was Don, who said, and I did a face palm at this because it's such a obvious thing, where I wondered why I didn't think of that, of course. He said I'd mark the wires before I wound the toroid. Well, duh, of course. So this wire's already got my 2 marks on it on this end where I was measuring. I'll just take my marker and I'll put a mark on this end so that after I wind the toroid I can tell which wire is which. Because if we go back to the diagram here, these wires have to stay in parallel. So you have nice, spacing between the winds, and each wind is 2 wires in parallel, and they can't cross over. They should always stay in parallel all the way around. But at each end, you need to identify them so that the center on this side goes to the center on this side, and the shield on this side goes to the shield on this side. You don't want to cross those over. You want that symmetry across the device. So I've marked the wires. Now, to help keep them aligned while winding, I'm going to cut a bunch of short little pieces of heat shrink tubing, which I'm going to put over the wires and shrink down, and that'll just help keep them together and make it easier to keep them parallel while I'm winding them. Okay, now we're going to start our wind. Alrighty, so I'm going to bring the wires about 2 inches or so hanging out from the end for making my connections, and I'll take them around for the first turn. Now I'm holding this side down with my thumb on one hand while I use my other finger to pinch those wires good and hard against that toroid, and I bring them around. getting that first wind is the most work. And then again, I'm holding it with my fingertip here while I bring that nice and snug around that toroid. Okay. And we'll put our wires through from the top. You definitely want to use solid core wire, no stranded, because the solid core will help to hold itself in place around the toroid as you wind. I think I said that in the 9-to-1 video. We'll get this first turn in here nice and tight. And then we'll put a zip tie on to secure it. And I'm using my finger to just push those wires down against the toroid as I push them through. And then I'll pull it taut after I've got that wind in there. And as you can see, we're already getting a nice clean pattern here. Okay, let's secure this end of it with a zip tie. Cut that off. All right, so we've now basically got 2 turns. You count them from the inside, right? 1, 2. So I've got to do 2 more on this side. Pass those through, pull them up, and then just pinch that down against the toroid good and taut, keeping those wires parallel, and bring it around and just do it again. There, good and taut. Okay, so there's 1, 2, 3, 4 turns for this side. Now, we're going to take it through the middle again, but I'm going to come straight across to the other side and then back up over the top. Then we'll push this through. Keeping those wires parallel and together. There's 1. Make sure you're going through this side of the toroid. Don't go back across your crossover piece there that comes across. Stay on this side of it. Two. Three, and our last turn. Four. And now I'll secure this side with a zip tie. And there, we'll clean up that symmetry just a little bit. That's why I like the solid core wire. It's easy to move things around and get them exactly like you want them. And there is our 1-to-1 choke. Just that easy. Like I said, this is an easy one to do. Okay, so that is how you wind the 1-to-1 common mode choke. Like I said, simple. Now I just need an enclosure with a couple of esso 239s to put it in. And for that, I'm going to 3D print one. So we'll hop over to the computer here and we'll design a little box to put this in. And then we'll go down to the bench and we'll solder it up and we'll be done.
verses, but it's tried to be common. Interesting.
Well, we're down here at the bench. This is the 3D printed enclosure. And I have two esso 239s, one on each end. And it's just the right size for the common mode choke. And I was just getting ready to solder it in. I was prepping the wires. Fits pretty tight. I probably could have made it a little bit longer, but it's actually going to be pretty nice and tight once it's soldered in there. Just the right amount of room. The lid for the box I might reprint. I don't know if you can see this, but this corner here I had a little bit of a lift up off the print bed. I didn't have the bed quite leveled right. The gap was a little too high there, and that first bead, that first layer, didn't get pressed down into the bed enough. It just kind of got laid on it, and it doesn't adhere. And when it doesn't adhere, the plastic, as it cools, shrinks, and it pulls up the corners. But that's not going to get in the way of this actually working, I think. This lid's probably going to be okay. This version of, or this box is not going to be weatherproof. This is just going to be for the temporary use field type of installation, where I take it to a state park or something. I'll use a more weatherproof enclosure for the permanent installation of the vertical in my backyard. But anyway, we have our esso 239s in here. I've got a solder lug for the ground on each side, plus the center pin. So all I need to do now is just solder this sucker in there. So I'm going to tin the wires on here, and then we'll get it soldered in, and our 1-to-1 common mode choke will be done. Tinning the wires with a little fresh solder on them just makes it easier to solder them into the connectors, because the solder's already on the wire, so it's going to take quicker, and that means less heat transfer in the box, which is important because this plastic will melt if I get heat on it. But I've been thinking about that. The ground lugs, you see I put the esso 239s on the inside, so the ground lugs are heat sinked by the connector itself, so I should be able to solder the wires onto those ground lugs without damaging the plastic shell. Come on. There we go. One end. And marking the wires ahead of time allows me to keep the wiring straight through, so the middle on this side is connected to the middle on that side. You don't want those crossing over. One nice thing about using a box that's just small enough is the heavy wire and the tension of the wires is going to secure that in there. That doesn't want to move now. It's held in pretty well just by the wires themselves, so that's a good thing. Okay, now we'll do the ground side. One. And the ground side over here. And this will do it. There. And that is our 1-to-1 common mode choke. All built and put in its box. I guess just to be absolutely thorough, I'll take my multimeter and we'll set this to continuity. Yep, continuity through and no shorts. So we're good. Nothing left to do but put the lid on, screw it down, and we'll be ready to put this to use in the backyard vertical project. Now, for those of you that are interested in how I modeled this box that I 3D printed, I did film that, but I decided I'd put it at the end of this video. So for those of you that were interested in just how to wind a 1-to-1 common mode choke, that's the video up to this point for you guys. And for anybody else that is interested in how I created this box in Tinkercad and then 3D printed it, that follows right here. Alright, I'm over here in Tinkercad, which is my new favorite modeler for knocking things out. It's so easy to work with. And the first thing I'm going to do, if I'm going to want to make sure this box is going to fit, is I'm going to take my calipers and my finished choke, and I'm going to measure its diameter, including the wires, so I can make sort of a stand-in. Okay, 41 millimeters. So I can make a sort of a stand-in dummy inside of here that I can use to make sure that my box is going to fit. So let's go over to Tinkercad. Alright, so I need a toroid. Here's a torus. We'll pull that in. And we'll make that 41 millimeters in diameter. Okay, now I've got a nice stand-in for my wound coil that I can use for sizing things. So my box is going to be a box, right? Let's start with a box. I know this is 41 millimeters wide, so I know I want to make the box at least a couple of millimeters wider than that. Now it's going to have a wall of 2 millimeters, so that's 4 additional, plus a couple of more to give room for the toroid to sit in there. So I need to add 6. So if our toroid is 41, we'll make this 47 wide. Okay. Now how deep do I want it to be? Well, I have to account for the esso 239 connectors that are going to be on either end. So I probably want to add another, yeah, I'd say another, let's say 15 millimeters at each end. So I'm going to add another 30. So if this is 47 wide, we're going to make it 77 deep. And how tall does it have to be? Well, I'm going to have to encompass an esso 239 jack on each end. And how big is an esso 239? Well, let's see here. Do I have one handy? No. But I kind of know it's about that big. Counting for a lid, let's make it 30 millimeters tall. Oh wait, I do have an esso 239 template right there. So the jack is going to need at least 25 millimeters of space to fit. I'm going to have a lid on this box, so I think, yeah, I'm going to make it about 30 millimeters tall. So we'll click on the height there, we'll make that 30. Alright, so that's approximately the size my box is going to be. And as I can see, my toroid's going to fit inside just fine. No problems there. Good. Okay, so our box has to be hollow. How do we hollow it out? Well, I know I want 2 millimeter walls on all sides, so I can simply duplicate this. Control D or duplicate. Move that off to the side for a moment. So I just want to subtract, not from the height, because we're going to hollow it out all the way to the top, but from the sides, I want to subtract 4 millimeters. Because this side's going to be 2 millimeters thick, this side's going to be 2 millimeters thick. So I'm going to take this down 4, so 43, and take this down 4, so 73. All right. Now I will align these two, select them both, click the Align tool. Now here's an interesting thing about the Align tool. It's going to align, or it's going to give you center points based on which box you have selected. So if I come over here and I click on this, now that I'm in the Align tool, you'll see that the center lines moved over to this box. So when I hit that, it's going to align this box into that one without moving that one. So I'll hit that one, and we'll come around here and we'll center it this way. So now my box is perfectly centered inside of that one. And the only thing I have left to do is I need to raise this one up. Right now it's right down on the build plate, and we'd punch a perfectly hollow hole through here all the way through. But I want 2 millimeters on the bottom as well. So I'm gonna raise this up 2 millimeters off the bed. I picked the wrong one. Undo. Yeah, there. Now I've got the inner box selected. I can see the outline. All right, so let's raise this up 2 millimeters off the bed. Make that a hole. I'm going to duplicate this hole and move it off to the side because I think I'm going to need it for something on the lid. So let me duplicate that, put it off to the side. Okay, back to this one. With them both selected, I'll group them, and boom. We just punched a hole. Now I've got my box. Well, all right, what do we need for our box? Well, we need corner pieces here that I can put a hole in for a screw. So I'm going to bring in another box. And I know I want about 3 millimeter holes, I think, for the threads on the screws I'm going to use. No, about 2.5 millimeter. Alrighty, so if I'm going to be putting about a 2.5 millimeter hole in the middle here, I'm going to want some material around that hole for the threads to bite into, right? So let's say about 1.5 millimeters of material around the sides for the threads to bite into. So 1.5, 2.5, 3, 4. I'll make it a little bit bigger than that. Let's just go with 5. A little extra material around the sides. 5 millimeters, 5 millimeters. And how tall do I want it to be? I want it to be up to the lip of this, right? So this is 30 minus 2 to account for the bottom would give us a height here of 28. And we'll move that in here. Tinkercad does not have a way to easily align with a point. But it does have a ruler tool. Let me pull a ruler in. And we'll put the ruler over here right on that grid crosshair. And we'll take this box and we'll bring it down to where it's lined up with the end of our ruler. All right, now what do I know about this box? I know that it is 2 millimeter wall here, 2 millimeter wall there. So ideally I want this hole to be 2 millimeters in from the ruler on either side. And you can see it, the ruler dimensions are out here. So I'm now 2 millimeters from the 0 point here, but I'm 4 here. So 1, 2, Now I'm 2 and 2, so I'm right at the edge of the internal wall of the box. So the ruler functionality in Tinkercad is kind of nice for that. Except that I need to raise that up by 2 millimeters. 1, 2, and now it is flush with the end of my box. Okay, so there is my one screw hole. I need to put the hole in it, so I'll bring in a cylinder and we'll make that 2.5 by 2.5, and it only needs to be about 10 millimeters tall to give us enough depth for the hole. And we'll raise that up to 20. Now it's 20 millimeters off the bed, which this is 30 millimeters tall, so that should be perfectly flush with the top of that box. And it is. So there's our hole. Got to center it in the box. So with the hole selected, I'll shift and select that little box, hit the align tool, click on the box because that's what I want to center against. Click the center tabs, and boom, our hole is now aligned. So that's going to be our corner piece. All we have to do is duplicate it 4 times and move it out to where it needs to be. So let me group. We'll select this and the hole, and we'll group those together so we've got our box with our hole. There it is. And I will do a duplicate, and we'll move it over to that edge. Looks like we're in the right spot. Now I'm going to shift and select that one as well, and I'm going to do a duplicate, Control D. And now I have a duplicate of it, and I can move these down to this end of the box. Bang. And now I've got my screw points. Okay, now I'm going to need a lid. All right, so let's see. How do I want to do the lid? I think what I want to do, I'm going to need to duplicate those holes because they're already positioned just right. Yeah. So I'm going to select, temporarily ungroup these boxes. Select them, ungroup them. Okay, now I've got my holes. I'm going to select those. Nope, I got the boxes, not the holes. Darn it. Deselect. Hole. Hole. No. Hole. Hole. Duplicate. Move them up. Okay, I've got duplicates of my holes that are all perfectly lined up where they need to be in the box. I'm going to move those off to the side. And we'll come back down here and group all this stuff back together. Okay, so that's all grouped together. So we've got our box with our holes, and I've got a duplicate of my holes. Now I need a lid. All right, so it's got to match this box, which is 47 by 77. So I'll bring another box over here, and we'll make it the same dimensions, 47 by 77. And its height. I guess a 2mm lid would be good. Now let's make the lid 3. Okay, there. So this is going to be our lid. Now remember I took those duplicates of those holes? Well, I'm going to bring those over, shift select that, align, center it, and center it. Okay, now they're centered. And if I select my lid and I lift it up to the holes, right there, see what I did? Now the holes on my lid are going to perfectly line up with the holes on my box. So we will group those together. There. Now I have a lid with holes. We'll move that off to the side. All right, the only thing left to do is I need to put SO239 connector holes at each end of this, so I can mount a couple of SO239s. Now I'm going to do a video on doing a virtual toolbox, because I've started to create some useful models that will be time savers in future projects, and this is a perfect example of it. I created a virtual punch for SO239 holes. What I did was I spent the time laying out 5 cylinders to mark the holes for the screw holes and the center part, the SO239, and I grouped those together and I saved them off as a separate file. So now I have what's basically a template for punching holes for SO239s, and I will import that model now. Go up to import, choose file, and in my models directory I have SO239 template, and here's the SO239 holes. I'm going to import that model, and there it is. So these are perfectly aligned holes for an SO239 connector. All right, so let's first off, we'll rotate this 90 degrees, and then we'll take it over here and we'll put it in the center of my, center of my box. Now here's another nice thing with Tinkercad. I want to align this with this face on the box. So to do that, I'm going to take the work plane, which is down here at the bottom, and I'm going to put it on the side of this box. Now you can see I'm my work plane, my work surface is aligned with that side of the box. So I'm going to take and shift select that and hit align, and I'm going to center it on my box. All right. There we go. Now I'll put my work plane back down here on the ground where I want it to be. And we have now got our holes punching. Oops, didn't want to move it that way. We've got our holes punching through the box. Just move them so they're about halfway through there. I need to put them exactly on the opposite side here, so I'm going to duplicate this, Control D. I just hit the up arrow to slide it up there to where it is going through that side of the box. All right. And now we'll just select the whole mess, and we'll group it together. Oh wait, these have to be holes. So I'll select that one, say it's a hole, select that one, say it's a hole. Now we'll take everything together and group them, and there we go. We have our box for the ballon, or for the common mode choke. Pretty cool, huh? All I need to do now is just export the parts for printing. Let's drop our lid down to the surface. Make sure this is sitting on the surface. Yep. And I can get rid of that torus. Oh, you know what? Remember I made this copy of this hole and I said I'm going to need that for my lid? Oh, what are we going to do with that? Well, let's see here. I want my lid to have a little bit of a depression that will fit into this square or this rectangular space here to keep the lid centered so it doesn't shift around. So what have I got? These boxes were so I need to shrink this hole down. Let's put it over the center of this thing. It's not going to be a hole, it's going to be a solid. And I know for sure I'm only going to want it to stick down about 2 millimeters. 2. Okay. And I need to shrink its size just slightly to account for the bead on my printer. So I'm going to take that down by 0.5. So we'll make that 42.5. And we'll make this 72.5. Okay, now this has to actually go smaller because it has to fit inside of these screw holes. What did I make those? Did I make those? Well, I've got a ruler. I guess I might as well measure it. Oh, it lines right up with that centimeter mark. So 1 centimeter in. So 10 millimeters. Actually, it looks like it's 9. No. No, it's 10. Okay. Or there's, let's see. 1, 2, 3, 4. There's 5. Yeah, it's 10 millimeters in is where this box is. Okay, so I want to make this extension an additional 20 millimeters shorter. So I'll make this 52.5. And accounting for the, we'll make it 52. Okay. Now we'll select our lid. We'll select that together. We'll hit align. Center it that way. Center it that way. I think that that's not right. I think that's not right. Let me move it up here and we'll verify that. Yeah, I think I'm too wide. No, it's okay that way. What about this way? Oh yeah, I made it much too small this way. How did I end up that far off? I know somebody out there is screaming at me, oh, you calculated this wrong, you calculated that wrong. So that needs to be another, let's take that to 62. There we go. Yeah, I was 10 centimeters off. Okay, so there we go. Now it looks like that plug is the right size. Okay, bring it back over here. And we'll bring it down to where it is 2 millimeters off the bed, so it is flush. How big did I make that box? Did I make it 3? Oh, I made it 3. Okay, so now it's flush with the top of that. And we'll just align it again. There we go. And then we'll group those two together. Okay, now my lid is done. So you see how that's going to work? That'll fit right inside there. esso 239 connectors, screw holes. And we have an enclosure for our 1-to-1 ballon. Only thing left to do is print it. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.